Hello all. Today we'll be discussing about next topic, that is object relational model. And today's outline we'll be discussing about object relational features, like user defined types and complex structures for objects. Then using this user defined types as types for attributes. Then object identifiers using reference types. Then creating tables based on the UDTs. Then we'll be discussing about encapsulation of operations, specifying inheritance and overloading of functions. So what is meant by this object relational model? So the relational model with object database enhancements is referred to as the object relational model. And we know that the SQL is the standard language for RDBMS. And this SQL was first specified by Chamberlain and Boyce, and this underwent enhancements and specializations in 1989 and 92. And then a new standard came up, and that was initially called SQL 3, and then later it is known as SQL 99. And starting with the version of SQL that is known as SQL 3, we have features from this object databases were incorporated into this SQL. Okay, so starting from this SQL 3, we have features from object databases. Okay, and at first these extensions were known as SQL/object, but later they were incorporated in the main part of SQL. Okay, and that time it was known as SQL/foundation in SQL 2008. Okay, so let's see some features of this object relational model, and this has been added to this SQL. The first one is we have some type constructors. Okay, so these have been added to specify complex objects. Okay, which means these include a row type, and this row type corresponds to the tuple or struct constructor. Okay, and we have an array type, and that is for specifying collections. And other type constructors we have like set, list, and bag constructors. All these are type constructors. And we have a mechanism for specifying object identity through the use of reference type. Okay, that is also included. So this object identity through the use of reference types. And we have then encapsulation of these operations. Okay, so that is this encapsulation of operations is provided through the mechanism of user defined types. Okay, UDTs that may include operations as part of their declaration. Okay, and these are similar to the concept of abstract data types. Okay, that were developed in programming languages. And we have the concept of user defined routines allows the definition of general methods. Okay, so we have user defined types as well as user defined routines. They are similar to operations. Okay, and the last feature is that we have inheritance mechanisms. Okay, so these inheritance mechanisms are provided using the keyword under. Now we'll see some user defined types and complex objects, complex structures for objects. So we'll be discussing about this user defined types using create type. And so that is for to allow the creation of complex structured objects and to separate the declaration of a class or type from creation of a table. So that is actually a collection of objects or rows, and that corresponds to extent. Okay, so when we talk about a table, that is an extent. So SQL provides this user defined types, and in addition to the 4 collection types, it allows for collections, that is multi-value types and attributes, in order to specify this complex structured objects rather than just simple records. Okay, the user will create the user defined types for a particular application as part of the database schema, and this user defined types may be specified in its simplest form using this syntax. That is, we have create type, then we will be supplying the type name as component declarations. So for example, consider we have create type street addr underscore type as so we are creating a new type as type underscore addr underscore type. This is the type name, and that is we have the component declarations. So they are number varchar of 5, then street name varchar of 25, then apt underscore number, it is varchar of 5, then suit number varchar of 5. So which means that we have a type, or we have created one user defined type, and its name is street underscore addr address underscore type. Okay, this is for street address type, and that includes, this is a complex structure, so it includes number, then street name. So a street address means it will have a street number, then street name, and then apartment number, then suite number, all this. Okay. So now using this UDTs as types for attributes. So here, for example, create type USA underscore ADDR underscore type as street ADDR. So here street ADDR is of type street underscore ADDR underscore type. That was just declared here, defined here, and city varchar of 25, then zip, that is varchar of 10. So what happens here? So we have this UDT, that is street underscore ADDR underscore type, and that is used as the type of for this street underscore ADDR, and this is an attribute. Okay. Then here we have a UDT, that is USA underscore ADDR underscore type, and this can also be in turn used as the type for some other attributes. Okay, and if a UDT does not have any operations, we can use, or it is possible to use the concept of row type. Okay, suppose that we do not have this any operations within that UDT, then we'll be able to use the concept of row type, and that is used to directly create a structured attribute by using the keyword row. So we'll be using the keyword row for creating a structured attribute. Then we'll be able to give object identifiers using reference types, and that is unique system generated object identifiers can be created using a reference type, okay, using the keyword ref. That is, as we can see, ref is system generated. That indicates that ref is system generated. It says that whenever a new person type object is created, the system will assign it a unique system generated identifier. And it is also possible not to have a system generated object identifier and use the traditional keys of the basic relational model if desired. And that is, in general, the user can specify that system generated object identifiers for the individual rows in a table should be created by using the syntax ref is. Then we can use this object identifier underscore attribute and value generation method. And now creating the tables based on the UDTs. So for each UDT that is specified to be instantiable, okay, and we can specify them via the phrase instantiable. Then one or more tables may be created. So here when we create a table person based on the person underscore type UDT. And here the UDTs are non-instantiable and hence can only be used as types for attributes. And but that is not as a basis for table creation. So here we have create table person of person type. So here we are creating persons of this type, person type. Okay, and ref is person ID system generated. Okay, then create table employee of employee type under person. So we know under is for this inheritance. As we move on, we'll see them. And encapsulation of operations. That is in SQL. A user-defined type can have its own behavioral specification by specifying methods in addition to these attributes. Okay, so the general form of a UDT specification with methods will be like this. That is, create type, then type name, then we'll be supplying list of component attributes and their types. Okay, then declaration of functions, their methods. So here in this example we declared a method age, okay, that returns integer. This will calculate the age of an individual object of type person type. And the code for implementing the method has to be written. And SQL provides built-in functions for user-defined types. For this user-defined type, for example, type underscore t, the constructor function type underscore t returns a new object of that type. Okay, and we can also define an observer function, and that is implicitly created for each attribute A to read its value. And we can have a mutator function for updating an attribute sets the value of the attribute to a new value. Okay, that will set value of an attribute to a new value. That is a mutator function. So likewise you can see many functions. So then we'll see specifying inheritance and overloading of functions. And in SQL, the inheritance can be applied to types or to tables. And SQL has rules for dealing with type inheritance. Both attributes and instance methods, that is operations, can be inherited. And we know that they will be specified under the keyword under. Okay, and the phrase not final, we have seen this not final, that must be included in a UDT if subtypes are allowed to be created under that UDT. Okay, if subtypes are allowed to be created under that particular UDT, we can use the phrase not final. Examples are person underscore type, then student underscore type, and employee underscore type are declared to be not final. And we have some inheritance rules also, and this rule says all attributes are inherited, or the order of subtypes, supertypes in the under clause determines the inheritance hierarchy. And an instance of a subtype can be used in every context in which a supertype instance is used. And a subtype can redefine any function that is defined in its supertype with the restriction that the signature be the same. And for dynamic linking, the types of the parameters are considered at runtime. And as we have examples, suppose that we want to create two subtypes of person type. One is employee type, another one is a student type. Suppose in addition to that, we also create a subtype manager underscore type. Okay, all this comes under this person underscore type. Okay, and these will inherit all the attributes of employee underscore type. Suppose this manager underscore type inherits all the attributes and methods of this employee underscore type, but has an additional attribute department underscore managed. Okay, and in general we can specify the local attributes and any additional specific methods for the subtype which inherits the attributes and operations of its supertype. So here also we are creating type grade type, as it has a course number, semester, year, grade. Then create type student underscore type under person underscore type. Okay, so this student is of person underscore type, or it inherits this person underscore type, and it will have this major code, then student ID, degree, and it says that it is instantiable, then not final, which means subtypes can be created, and we can define a method GPA, and that will calculate this GPA and it will return a float, etc. Okay, that is, we have defined this object relational model and we discussed about some features.